Good afternoon everyone and welcome to my YouTube channel. So as for today, we are proving whether a function is odd, even or neither. So if you are new, you can just kindly like, subscribe and share for more. So the question says prove whether the function is odd, even or neither. So now a quick hack that we can be using is this. So how do you know what you are looking for? So from the onset of the question, you can be able to determine whether a function is odd or even. So just look at the power. If you look at question 1, we have power 4, we have power 2. So 2 and 4 are even numbers because even numbers are divisible by 2. If they are both even numbers, it indicates that the function is even. Let's look at this one. It has got power 5, power 3 and power 1. 1 is an odd number, 3 is an odd number, 5 is an odd number. This means to say the whole function becomes an odd function. Last but not the least, f of x is equal to x squared minus x plus 1. This one is neither. Why is that so? Because this one, power 2 is even, this one is odd, power 1 is odd. So now, if both of these we have odd and even, it means to say it's neither, because the function can neither be odd and even at the same time. It cannot be both at the same time. So with that, let's be able to solve this one. So now, knowing the answer that we expect, we can just be able to go direct. So our f of x is equal to, we have a 2x to the power of 4 plus x to the power of 2 plus a 5, like that. So how do we test for odd? For even. So testing for even, we are going to say f of negative x should be equal to f of x. We already know what f of x is equal to. So all we need to do is, let's find now f of negative x. This one is equal to, what are we going to have? So this means that where there is x in the original function, we are going to put negative x. So we have a 2, open brackets, negative x to the power of 4, then we have plus, open brackets, negative x to the power of 2, then we have plus a 5, like that. So we are going to have, now we have a 2, then negative x raised to the power of 4, if it's in bracket it will be positive x to the power of 4, then negative x to the power of 2, we are going to have plus x to the power of 2, then last but not the least we have a 5, like that. So now, as you have seen, we have the same values. So as you have seen here, we have the same values there. We have the same equation. Therefore, you can say that since f of x is equal to f of negative x, then it is even. So if you already know what you are proving, it's very much simple to answer the question. So you can end there for that one. Let's look at our part B. So part B says that we have a question such as f of x should be equal to x to the power of 5. We have then plus x to the power of 3. Then we finally have plus x, if I'm not mistaken. We have plus x there. So this one, just from the onset, we are able to determine to say this is odd because 5 is an odd number, 3 is an odd number, and 1 is an odd number. So let's be able to answer it. So we can say if it is odd, we already know that it's odd. So we are going to say f of negative x should be equal to negative of f of x, like this. So we are going to have our f, let's find our f of negative x. This one should be equal to, where there is x, I'll put from the original equation, I'll put negative x to the power of 5. Then we have plus our negative x to the power of 3. Then we have our negative x, like that. So what do we have? So negative x to the power of 5, it's still negative, so we have negative x to the power of 5. Likewise, negative x to the power of 3 will give us negative x to the power of 3. Then we have minus x, like that. So we have found the first part. let's see if our other one will also give us the same thing. So our negative f of x implies that we just put a negative before f of x. So each and everything that makes f of x, we are going to put it in brackets. So we have x to the power of 5 plus x to the power of 3 minus x, like this. So we are going to open the brackets. So we have a negative x to the power of 5. This times this, we are going to have negative x to the power of 3. This times this, we are going to have, the original equation has got plus here. Then we have minus x, like that. So since these two are the same, this one and this one are the same, we can be able to say that since f of negative x is equal to negative f of x, we can say it is odd. Let's look at our last problem. So remember, for this one, we said that this one is neither. So what are we going to do? So since it is neither, automatically, we are going to just prove. We are going to say, here we have to prove both, because we know that it's neither, but we just have to prove it. If it is odd, we can say, okay, let's begin with if it is even. If it is even, f of x should be equal to f of negative x. So to find the f of negative x, we have f of negative x should be equal to, where there is x in the original function, we are going to put negative x. Then we have squared, we have minus, we have open brackets, negative x, then we have plus a 1, like that. So we have a result such as x squared, negative times negative, it will be plus x, then we have plus 1. So as you have seen, these two are different. So we can be able to conclude. So as you have seen, the two are different. So if these are different, you can say, since f of negative x is not equal to f of x, it is not even. So let us also prove for odd. If it is odd, we are able to say the f of negative x should be equal to negative f of x, like that. But from our previous problem, we know that f of negative x should be equal to x squared plus x plus 1. Not to waste time on that one. From this one, we already know what f of negative x is equal to. So now, all we need to find is negative f of x. So how do you find this one? Remember what we were doing? You just attach a negative, then open brackets, you write what your f of x is equal to. So if you remember your f of x, it was equal to x squared, then we have minus x, then plus 1. So if I multiply, I'm going to get a negative x squared, then I'll have plus x, then I'll have minus 1. Now, as you have seen, those two are different. So this one and this one are different. So therefore, you can be able to conclude to say, since f of negative x is not equal to negative f of x, you can say it is neither odd nor even. So that is how you conclude on that one. Thank you very much for watching my video. Hope you would like, subscribe, and share for more. See you on the next tutorial.